Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS3452, Theory of Computation, Unit 4, topic Closure Properties of Context-Free Language. Objectives to understand the closure properties of context-free language to prove closure properties of context-free language. Closure properties of CFL. Will be accepted by push-down automata. Context-free languages can be generated by context-free grammars which have productions. So we are going to substitute in the form A tends to rho, where and N is represented as a non-terminal and T is a terminal. Now we are going to see some of the properties of context-free language. Properties of context-free languages. First one, union. If L1 and L2 are two context-free languages, their union L1 union L2 will also be context-free. For example, L1 consider one set of grammar. For L2 we are going to consider set of grammar. That means here L1 says number of A's should be equal to number of B's, and L2 says number of B's should be equal to number of C's. Therefore, the union says either of two conditions are to be true, means it is also a context-free language. Next, we are going to see the concatenation. If L1 and L2 are two context-free languages, their concatenation L1 into L2 will also be context-free. For example, for the L1, L2 and L3, we are going to, here the L1 and L2 are grammar. From that we will get one answer that will be stored in the L3. That means L1 says number of A's should be equal to number of B's. Here L2 says number of C's should be equal to number of D's. That the concatenation says first number of A's should be equal to first number of B's. Then only the number of C's should be equal to number of D's. So we can write a push down automata with will first push for A's, pop for B's, and then we are going to for push C, then only you can able to pop D. So it can be accepted by the push down automata. Then next one is clean closure. Here L1 is a context free. Its clean closure L1 per asterisk will be also be a context free. For example, L1 equal to A power n, B power n should be greater than or equal to 0. L power 1 power asterisk means A power n, B power n greater than or equal to 0. It is also a context free grammar. Next, we are going to see intersection and complementation. Here, if L1 and L2 are two context-free languages, their intersection L1 intersection L2 need not be context-free. So, here also you are going to consider the conditions L1 and L2. That means L1 says number of A's should be equal to number of B's. Then L2 says number of B's should be equal to number of C's. Then only you can able to do the intersection says both conditions need to be true, but in the push down automata can compare any two. So it can be accepted by the push down automata. It is not a context free. Similarly, you can able to do for the complementation of context free language. It is not be a context free grammar. Thank you.